All right, so how do we use heat in a equation? Okay, so what we're doing here is we're going to solve this equation using stoichiometry. Okay, so for example, it says how much heat will be released when 6.4 grams of sulfur react with excess O2 according to the following reaction. So what's this telling us is if I have 6.44 grams of sulfur, how much heat am I going to produce? So the first thing I'm going to do is I'm going to solve for the number of moles of sulfur. So I know I have 6.44 grams of sulfur. I'm going to multiply that by, I know that 1 mole of sulfur. And then I go to my periodic table is 32.07 grams of sulfur. So now if you notice, if I set this correctly, gram of sulfur is going to cancel out. So that's going to give me the moles of sulfur. So all I want to do is put in the calculator, 6.44. divided by 32.07 equals, so this gives me basically 0.200 moles of sulfur. So now, based on my equation, I know that 2 moles of sulfur will produce negative 791.4 kilojoules of energy. So it's an exothermic reaction. So I'm going to take my 0.200 mole sulfur. So notice I don't have 2 moles of sulfur, I only have 0.002 moles sulfur. I'm going to multiply by this relationship. So I know I only need these two. So 2s would be on the bottom because 2 moles of sulfur is going to be on the bottom, and that's going to be negative 791.4 kilojoules. Now again, I come to double check. Notice moles of sulfur will cancel out moles of sulfur. I forgot to get sulfur there. So now notice what the units I have left, which is kilojoules, and that's what I need. So all I have to do now is take that 0.2 and multiply by negative 791.4, and I have 158.92 kilojoules, and that is my answer. Don't forget this is negative. Okay, so if 2 moles make 791.4 kilojoules of energy, then 0.2 moles would only make negative 158.92 kilojoules of energy. Now, let's do a problem that basically take this process and go backwards. So here, notice I'm given the amount of energy used. Okay, so I'm going to start with that. So I have 76,000 kilojoules. Okay, and I know my relationship is for every 2,220 kilojoules, I'm going to produce 1 mole, or I'm going to burn 1 mole of C3H8. So I'm going to use that relationship in my math problem. Again, I'm going to put negative 2200 kilojoules on the bottom, and that makes 1 mole of C3H8. So notice again, kilojoules will cancel. So now all I have to do is do the math. So I have 76,000. I'm going to divide that by the negative 2200. But in this case, I'm not going to worry about the negative. So I have basically 34.55 moles of C3H8. So now all I have to do is take this moles of C3H8, so 34.55 moles of C3H8, and I'm going to multiply that by the molar mass. And the molar mass of C3H8 would be 1 mole of C3H8 is 3 carbon, which is 3 times 12, plus the 8 hydrogen. Add 8 more, makes it 44. So this is 44.00 grams of C3H8. Again, I'm checking my units. Moles of C3H8 cancels out moles C3H8, leaving me with the problem. So now all I have to do is take my 34.55, and then what I'm going to do now is I'm going to multiply that by the 44.00 grams, and I get 1,520.2 gram of C3H8. So what it means is I'm going to have to burn 1,520.2 gram of C3H8 to produce that 76,000 kilojoules of energy.